Alright, in this video we're going to talk about section 6.3, day 1, ellipses. So we've already talked about parabolas. That was our first type of conic section. Second type that we're going to talk about is an ellipse. So you see on the screen right now the definition of an ellipse is the set of all points in a plane, the sum of whose distances from two distinct fixed points, called the foci, is constant. Then you can look at figure 6.8 right below it to kind of see what we're talking about. So if we look at this right here, we have one focus, D1 would be the distance from this focus to the point in question, D2 would be this one. So if you figure out the distance here and the distance here and add them together, you're going to get some number. If you move and go from, say, this point here, this distance plus this distance is going to be the same as this distance plus this distance. So it's the same all the way around. Now an ellipse is going to have two vertices, so we have a vertex here and a vertex here, a center, a major axis, and a minor axis. So the vertices are going to be the endpoints of the major axis. You'll notice that the major axis and the minor axis are perpendicular. They intersect at the center. And the only difference between the major axis and the minor axis is the major one is longer. So in this case, the major axis is here because it's longer. The minor axis is here. Now, our standard form of our ellipses are going to be x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Or you switch a and b, and that's going to be as well. So if we look up here, a is going to be bigger than b. So if the a squared is under the x, if the number under x is bigger, you're going to have a horizontal major axis like the one we just saw a second ago. If the bigger number is under the y squared, then we're going to have a vertical major axis, so it'll look like this. Something to note is the length of the major and minor axes are 2a and 2b respectively. And the other thing that we need to know is that the foci lie on the major axis and they are c units from the center. So when we were talking about parabolas, we had P. P was the distance from the vertex to the focus. Now we have C. C is going to be the distance from the focus to the center, and our equation here is going to be C squared equals A squared minus B squared. So let's kind of jump in, look at an example, see what we have going on here. So we say we have find the standard form of the equation of the ellipse having foci at negative or 0, 1 and 4, 1. And a major axis length of 6. So if we're kind of looking at what's going on here, we have this point 0, 1. We have this point over here, which is 4, 1. And we know that the length of the major axis, so we know we're going to end up looking like this. It's a really terrible one, but that's what we have. We know the length of the major axis is going to be 6. So from kind of playing around with these things, we know that the center is going to be just that. It's going to be the center. So it's going to be halfway between our two foci. So we know the center is going to be halfway between 0, 1 and 4, 1. So that puts our center at 2, 1. So we know right off the bat, now we can say, well, x minus 2 squared over something plus y minus 1 squared over something equals 1. We just need to figure out what's going to go here and here. We need to figure out our a squared and our b squared. Since we're going horizontally, we know that our a squared, the bigger number, is going to go under the x. So if we look, we got to figure out what that a is. We know the major axis is this way. And we saw that the major axis is going to be 2 times a. So we know a is going to be equal to 3. So we can put a 3 squared in the denominator there. Then if we look at our focus and our center, we know that this is 2 spots away from here, this center is 2 spots away from that focus, so we know that C is equal to 2, but we also know that C squared is equal to A squared minus B squared, so we know that 2 squared is going to be equal to 3 squared minus b squared, so 4 equals 9 minus b squared. Move the b squared over, move the 4 over, we know b squared is going to be equal to 5. So if a b squared has to go right here, we know that that's going to be 5. So our final equation, our standard form, is going to be x minus 2 squared over 9 plus y minus 1 squared over 5 equals 1. And again, we're going to put the 5 here because if we look at our standard form, it says a squared and b squared. Well, we know b squared is this. It would be silly to figure out what b is if we're just going to, square root of 5, if we're just going to end up squaring it to put it under here anyway. So x minus 2 quantity squared over 9 plus y minus 1 quantity squared over 5 equals 1. So the next example we have is going to ask us to do a sketch of the graph. So sketch the ellipse given by x squared plus y squared plus 6 minus 8y plus 9 equals 0. So the trick here is we want to put this in standard form. If we know standard form, we know the orientation, we know if it has its horizontal axis being major or minor, we know the center, we know the vertices, we can figure all that stuff out. We just need to know what the standard form is. So this is going to actually have us complete the square 2 different times. So what we're going to want to start with is we want to group together the x's and the y's. And let's move that 9 to the other side. So if we're going to complete the square, we want to do it twice here. We want to do it for the x's and the y's. So looking at the x's, we're good to go, but we have a problem with the y. When we go to complete the square, our leading coefficient has to be 1. So we're actually going to rewrite this problem by factoring out that 4 first. So we're going to still have the 6x, or x squared plus 6x. That's fine. We don't need to do anything with that. But we do need to say plus 4. Oops. And then we worry about completing the square here, right? We need to have our leading coefficient as 1. So we can say y squared minus 8y equals negative 9. So what we want to think about is we need to think what number is going to complete the square, what number is going to go in here. So we take the middle term, divide it by 2, so 6 divided by 2 is 3, and then we square it and add it here. So if we're squaring it, adding it here, we're adding a 9 here. We need to add a 9 over here as well. Doing the same thing over here. Oops, I made a mistake. We don't have an 8y here anymore. If we factored out a 4, we actually have a 2y. So if we take that 2y divided by 2, we're going to get negative 1 squared is 1. But we don't want to add 1 to this side because we're not really adding a 1 here because we have that 4. If we were to distribute, we're going to have a 4 times 1, so that's what we want to add to the other side there. Then all we have to do is factor. This is going to be x plus 3 quantity squared. This is going to be 4 times x minus 1, y minus 1 quantity squared. Negative 9 and 9 are going to cancel each other out, so we're going to be left with just a 4 there. And if you look at your standard form of the equation, this number has to be a 1. So we're going to divide everything by 4. So we're going to get x plus 3 squared over 4, plus our 4's are going to cancel, so we're going to say y minus 1 quantity squared. And we're going to go ahead and put that over 1, even though we don't need to. It's going to help us look at the graph a little bit easier. And that's going to equal 1. So since the number under the x is bigger, we know that we're going to be having horizontal here. We know the center is negative 3, 1. And since we know, let's see, 1, 2, 3, enough. Since we know that this right here is a squared, we know that a equals 2. since we know that this right here is b squared, we know b equals 1. A and b are just how far from the center it is to get to your vertices. So if we go 2 spots over in each direction on the major axis, and then we go 1 spot up and down on the minor axis, and we connect them really terribly, we get what should be an ellipse but looks more like a rotting potato for our graph here. So we have one more example, and then we'll call it quits on this video. So on this one, they want to find the center, vertices, and foci of the ellipse that we have seen here. So we want to start the same way. We got to complete our square. We got to put this thing into standard form. So group the x's and y's. Take this -8, move it to the other side. I can't have a 4 here, so let's factor a 4 out before we do anything. Alright, so we're doing this. We take -2 divided by 2 is -1 squared is 1. But we're not adding 1 to this side, we're adding 4 times 1. 4 divided by 2 is 2, squared is 4, so we're going to add another 4 to that side. This is going to give us 4 times x minus 1 squared plus y plus 2 squared equals 16. We can't have a 16 here, so we divide everything by 16. 4 over 16 is going to give us x minus 1 quantity squared over 4 plus y plus 2 quantity squared over 16 equals 1. So we know straight away that the center is going to be 1, -2. The vertices are going to be on the major axis. So the major axis is going to be the y-axis this time because 16 is bigger than 4. So we know that A is going to be equal to 4. So I need to go 4 up and down to get my vertices. So it's going to be 1, 2, and 1, -6 would be my vertices. Go up 4 and down 4. And the foci are going to be C places away from the center. So remember that C squared is going to be equal to A squared minus B squared. So C is going to be equal to plus or minus the square root of A squared minus B squared. So looking at what we have here, it's going to be plus or minus the square root of 16 minus 4, which is plus or minus the square root of 12, which is plus or minus the square root of 2 radical 3. So our foci are going to be at 1, comma, if we were at -2, we can go up 2 radical 3 places and down 2 radical 3 places, and those are going to be the foci. So A and B tell us how far we are from the center to our vertices on our major and minor axes, and C is going to give us how many spots we are to get from the center to our focus. So that's going to do it for this video. We will see you in the next one.